Hello, hello, hello. Great. Hello everyone, welcome to the stream. Today we'll be doing part 2 of lighting. Since we didn't get that far yesterday in terms of lighting, just in engine code. This time, yes, lighting and Vulkan. Mute these, mute this, and replace this link. There we go. You see, this is so random. Here it's bigger, here it's smaller. Does it depend on the URL? Does it depend on what? How long this is? It could be actually. It gets to here. No, not sure. All right. So we have a ton of stuff to do. First of all, let me make sure this compiles. Okay, we're good. Let me make sure we have pushed everything. Okay, so it all works. You're early today. Yeah, somewhat. Somewhat early, someone not early at all. Because before I used to stream at 10 a.m. my time. Anyways. We need our fragment shader. And that's it actually. We're just gonna init this to zero. Wait. I mean, we can init this to Coral. What was it? Coral? This. It's 2 a.m. where I am at right now, so it's pretty early. Oh. Wait, where are you at? 2 a.m.? Because, like, already China with me has only 12-hour difference, right? But you have 14. In Asia, that's all I can say. Okay. Fair. Hello, Kefele. What are you working on? So yesterday we introduced shader objects and dynamic rendering, which are two new ways of rendering in Vulkan. They are supposed to make your code smaller and supposed to be less verbose and more correct. Well, not this one. This one is more of a new thing. But this one, yes. And we spent the entire day doing that. It took like 7 hours. And we were planning on doing colors. Well, not colors, lighting in general. Ideally, I get to I don't know, multiple lights seems like a good goal for today. So blend fong and whatever, and maybe even shadow maps. That would be interesting. Normal mapping. Yeah, it can be a Chihuahua. I mean, definitely here, unless we find some weird Vulkan bug. But it's mainly today gonna be about lighting and making this scene look less sad. And tomorrow I'm gonna work on making the previous OpenGL render that I had work exactly the same like this one and vice versa. So it load meshes and whatever. That's today. Good luck. Thank you. Why not use the biking room model instead of a box? Because the biking room model doesn't have diffuse textures and other stuff. Also, it has baked lighting, doesn't it? Might I have it here? First of all, biking container. I'm pretty sure it has baked lighting, and yeah, I mean, I need the diffuse and specular shadows. What does it do? This is so useless. Wait. What am I doing? Okay. That, and of course I need to use textures again. Or whatever, I was trying to do something else. This. Okay. There you go. You see that it has baked lighting and no specular and whatever. I'm also working on my graphics engine using OpenGL. Great, we're at finally stream high. Yeah, it took a bit longer to wake up today. Biking room. Does that work? Oh, yeah. So these are textures, this our thing. Let's continue. In the upcoming chapters, we will be creating an interesting visuals by simulating real-world lighting, making extensive use of colors. Since now we'll be using light sources, we want to display them as visual objects in the scene, and add at least one object to simulate the lighting from. I need to connect my headphones. The first thing we need is an object to cast the light on, and we'll use the infamous container cube from the previous chapters. Okay, then they say about the lighting BAO and whatever that we couldn't make before. So we can basically... Okay, it takes pretty much the same data, right? Record command buffer. Can we just do this and... Okay, first of all, can we bind, can we update uniform buffers? What do I have to give it? Current frame? Am I passing it here? That's image index. Isn't image index current frame anyways? Why is it not here? Oh. No, it's image index and command buffer current frame, okay. So I update uniform buffer with, let's say, no, nothing. I mean, I just do this at the start of begin rendering. Does that work? So I have to do it right before BK rendering? No, I need to do it right before begin command buffer. Right, so the thing is I'm updating it twice, no? First of all that. Okay, now I added at the top here, current frame, nothing changed. It still doesn't work. That's odd. Okay, and now this doesn't work either. I thought you should update the uniform buffer before draw command, right? Yeah, that's what I thought. was needed. I just wanted to make sure that tier is correct. Okay, now it's not even building. What? What changed? This is no, we're loading the container whatever, and oh, my bad. I don't know, I have something. I have something wrong. Okay, so how about I do it right before drawing? So there's this entire setup and I update the uniform right before drawing. Okay, it looks fine. So then I update it and then I draw again. Yeah. Okay, and this second one that I make can be update uniform, update light object uniform buffer or UBO. And it's like around the same thing, except this is 0.3 here, right? I'll just add it at the top of this because I'm too lazy. So update light obj UVO. The earlier is better, I think, because it will be having 1 frame delay. Yeah, I know that. But you should keep it at the top of record command buffer and only light be after being drawn. Okay. That's fair. Anyways, it's rendering one, but the other is not there anymore. I think it's because since they share the same UBO, it doesn't work, right? So if we do it before the frame, this is pretty hacky though, already. No, it doesn't work either. So we're doing it before beginning the command buffer. And at the end of here, we update the UBO and do the same rendering with the same vertex buffers. Yet that updates this cube, not the one that we want to be drawing. Like if I do 7, it should go up, as if it was the same one. Do you even bind two vertex buffers and index buffers? No, I wanted to try with one. It's normal to be confused, guys, don't worry. So I update here. I do the exact same thing, except I update this before. So this is draw light object. We reuse pretty much everything. Yeah. We reuse everything, but bind it twice. Yeah, I want to draw 2 cubes. I was hoping it would draw this one first, and then when I changed the UVO the second time, since I'm drawing twice, it would update the position of the cube. But it doesn't. Do you have the same logic in both? No, I mean the UVOs, no. I have this logic for this one, and then for this one I have another one. What I think is maybe I can map it to another uniforms buffers map. It could be like light OBJ UBO mapped. Then you have uniform buffers. Do I have to create one for each of these two? Do you translate the cube using transform matrix? Yeah. Both have different transformations. It's confusing as fuck. What are you confused about? I'm trying to draw 2 cubes with the same shader, right? I'm trying to find out if I can use the same UVO, just drawing twice in the same draw call. Do I have to create another record command? Do I have to create another UVO? Kind of like that. Yeah, that's what I'm planning. You can, but you need to bind vertex and indices second time I think. I did and it didn't work either. Is the second cube outside the frustum? No. Thanks for the follow, W1RY4. What does this program do? It renders a cube that spins. Well, not anymore. Okay, what happened now? Wait for fences, invalid fence. What? Open render deck, yeah, let me see what is going on. Why do I get this? I was not getting it before. There we go. Okay, let's see what render doc says. So we do basically the same thing we were doing before. This is for draw cube. This has pretty much all of this. And then this is draw light object. We will reuse that and that. So we bind the vertex buffer we were using before, the index buffer. So vertex input, index buffer, vertex buffers, and draw indexed. And we need to use before this update light object this and render current frame. Okay, render doc. Let's see. This is the same from last one, no? Yeah. F12 and escape. So it's already interesting. The first time it calls, it has this for the vertex attributes. Is there a way to see the UBO? Oh, here it is. And then the UBO has these values. So 79335 and whatever. And then on the second call, it has the same. When it should be different already. And there should be only for vertex shader. Click white box on timeline. So this is Q submit, Q percent. This first, no, this rendering, and this is first one and second one. First one does all of this and then draw index. Second one does all of this. It doesn't show that we're updating the UBO though. Anyways, you can see that the UBO is exactly the same, right? Click mesh viewer. Geoposition this and the same, yeah. Okay, so if I want to render two objects with the same shader, do I need then different uniform buffer mapped values? No. So make a second UBO. Well, that's what I was thinking, right? But you should be able to use it for all objects, even if 4,000 objects, really. Then what is wrong? I mean, I can get if it is different shaders, but if it is the same one, it matters. Maybe the problem is that it can't be updated twice a frame, right? Always for stuff like this, model matrix, I use push constants. Yeah, I was thinking about that for just MVP, since it's pretty simple. But anyways, I need to make it work for more complex data, like if it takes lighting positions or whatever it needs to know. Use the same UBO to draw multiple objects in Vulkan. The thing, right, is we are updating the UBO twice on the same command buffer. I bet if we did two command buffers, then it would work, but it already loses the purpose it had before. I know you can use one pipeline to draw in two or more textures, but I don't know about UBO. Glow stuff, sets up, yeah, whatever. One or more descriptor sets that bind resource references in shader to state and data in Vulkan API objects. You don't necessarily have a distinct API objects for each drawable. Instead, your drawable might have the data and you obtain an API object like a descriptor set and fill it in each time you draw, then recycle it. Or you might have a BK buffer shared by many drawables, with each drawable geometry occupying a sub-range of that buffer. So that's one option. But it's already more complex than I was wishing. UBO is also slow. For example, you don't typically change it per object. Yeah, I mean, I would use UBO mainly for lighting. And then push constants for each model, I guess. I was just wondering if it is possible. Draw indexed. Right, this is what is Sasha Williams doing here. Then I would make another set of independent UBOs. Okay, so let's do that, just to try. Let's do that just to try, and then I'll try to reuse the same UBO but for different shaders and see if it makes an effect. So this is the only place it's set. It creates all of this. I'm guessing, do I need to create uniform buffers and uniform buffer memory twice? Like, do I need all of this? Again, light obj. Descriptor pool is the same, yeah. But then buffer device memory and the actual mapped memory, yes. Okay. Light UBOs. Light UBOs. Memory. Light UBOs mapped. Okay. So when I create this, I do the same thing. Right. This is light UBOs memories. Mapped and uniform buffers, light. Okay, where's buffers? Uniform buffers. Okay, so that's they're no longer light arbitrary UVOs. And then memory again is this. And then you just light UVOs. Memory. Mapped. The naming is terrible. Okay, first let me see if it compiles. Like it. I don't get why why I get that error if I didn't change anything related to that. There we go. I forget to destroy them, but I can delay that for now. Update UB light UVOs. And here I just use light obj UVOs mapped. Right? Yeah. And I think that should work. What? Yeah, in descriptor pool, you also need to make another, you think? You have different, and in pipeline creation, you need to set both. Is that it? I'm not doing pipeline creation. I just have pipeline layout. This. Then I set the shader descriptors once. Same thing for me. Shader shader objects here. I set the descriptor layout, and the descriptor layout is independent, no? Like you create it, there's the binding, yes, and that's it. And on rendering code, I just bind it before using it now. Never mind, that is bound to the shader anyways. Render descriptor set layout set to vector of in pipeline layout. Vector of both light, normal, pipeline layout, render descriptor set layout, whatever you're saying. Render descriptor set layout. What do you want me to do here? Descriptor count 2? No. You made descriptors for those light UVOs? No, I didn't make descriptor sets. Since they use the same shader, right? To this layout, add another binding. Right. It could be 3 and... light layout binding. Light UBO layout binding. This is 2. It's on the vertex and yeah. And when I use this, binding 0, so binding 0. And now in descriptor pool, this is already getting too messy, no? Descriptor type uniform buffer, descriptor count. And it would be the same thing as in this. But then what do I need the descriptor pool for? Like, do I set another binding? Because I also have to do descriptor rights. And this contains also 2. Oh god. So much boilerplate. Rights 2, yeah. That's the same. And then the only thing that is different is this. And it takes buffer info. Okay, go back. Which is the size of uniform buffers. Do I have to create another one for... What was it? Light buffer info. Light obj UBOs. I feel like this is already... I don't think it should be like this. It feels off. It feels wrong. This is not the way that we should be doing this. What happened? Image info, buffer info. Oh, it's because I'm using that. It feels so inefficient. Yeah, to type. I mean, you have to abstract so much if this is the case. So this, of course, and then descriptor type uniform buffer is different from binding 1. This is on update descriptor sets. Update. What did it do? Oh, DST binding. Right. Okay. And now finally, what? Like this just adds another uniform binding, right? But it doesn't change anything. Right now, what I would do is I would set the descriptor and the descriptor set binding to the second one. Bind descriptor sets. Is that the binding? First set, descriptor set layout. Layout? Is that it? No. Did he change the shaders? No, it uses the same shader. Yeah, that's what I was thinking. But even that gets messy because you have to use the Vulkan buffer and you have to create it before and it needs to hold that amount of data. Right? No? What do you mean? You create the UBOs and you have to... well, I don't know this point. I wanted something more dynamic. There are push constants. Which I guess is what we're gonna do for now. Let me redo whatever we changed here. Go back. I'm gonna look it over. Maybe there's a better way to do all of this. But as of now, there doesn't seem to be a better way. For what I can figure out, of course. New pipeline layout. We're going to need a new pipeline layout to hold the push constant sizes. For that, we're going to add a new member to Vulkan engine pipeline layout. And then it's that. You can use an existing one, I think. I hope. Light object push constant. So what do? They create the pipeline layout, and on the pipeline layout, the init create info. Okay, that's normal. Push constant, offset, mesh push constants, and the shader bit. Okay, pipeline layout. Okay, luckily this isn't too verbose anyways, right? I'll create it before. No. So we have no offset. The size of this will be... I mean, we literally want the same thing, right? So let's name it MVP push, MVP obj object. That's all we want. Call it push constant. And then here I just do pipeline layout info push constant ranges. Push constant range count 1. That's it. Ranges the pointer count, and you create and it's only used on the vertex shader. Anyways, we can just send it to the fragment shader if we need any of that. Push constants are written in ranges. Important reason for that is that you can have different push constants at different ranges in different stages. For example, you can reserve 64 bytes 1 GLM at 4 size on the vertex buffer and start the pixel shader push constant from offset 64. Oh. Right. So it seems like this is the way they do it. They just use offsets for each object they have to render. In different stages, for example, you can reserve 64, 1 GLM at 4 size of on the vertex shader, and then start pixel shader push constant from offset 64. This way you would have different push constants on different stages. Anyways, a push constant is like 128 only, no? Given that getting the ranges right is tricky. In this tutorial we're going to use a more monolithic approach of using the same push constants on both vertex and fragment shaders. I mean, we're not going to use them on fragment shaders. Anyways, they are just adding that bit. Now that we have the layout, we need to modify the shader at the push constant. like that. So vertex, I guess we can keep this. They name it push constants. And what is this? Push constant. Is that an actual keyword? Yeah, it seems like so. And it's also a uniform. In constants. Min 128, but 256 standard for desktop GPUs, right? Hey man, how are you? All good. How about you? Okay, so let's comment this out. I wonder if it's gonna optimize this, and when we try to push uniform buffer objects, it's not gonna accept them because wait, this is wrong. Constants in constants. Yeah. I don't think you need a projection there, since you'll be using camera's projection in view. I mean, technically I don't need any of these ones, right? I could just multiply them before sending them to the uniform, but I let the GPU do it. Great man, thanks. What keyboard are you using? I am using a... what was it? HyperX... I mean that you get view and projection from UBO. Oh yeah, I know. But I don't want to use UBO for that. HyperX... Alloy FPS. It's this one. Alloy Origin Core. Not sure, it's like one of those. Anyways, they have the same switches. Why not? I mean, we can use it to try, right? But no. I don't want to use any of this for anything. Like, here I want to store the light count, for example, like, I don't know, int spotlights and spotlights count, and then spotlights, something like that. UBOs can be very big, push constants are per object. Yeah, that's what I'm saying. Since this can be very big, I just push the matrices here and get this out. That's why I asked, this sounds so similar to mine. Yeah, I mean the red switches are recognizable. Mat4 is 64 bytes. Is that it already? Is it? No, it's 16. It should be, no? Because that's where you can do SIMD on it. Back 2 is 16. Are you sure? Because they have a 16-byte alignment. I mean, I don't know how the GPU memory works, right? But before you send it, you always align it by 16, and if not, you add an offset. It said there 64 bytes. Therefore, while a map 4 occupies 64 bytes of memory, the 16 bytes typically refers to the required memory alignment for optimal performance. Oh. Unlucky. Oh, my bad. I'm thinking it wrong. It's because back 4 is 16 byte. Yeah. Yeah, I was wrong. It's back 4 that is 16. Anyways. They do data and render matrix. So they do all the calculations beforehand. Then I guess I can do MVP directly. MVP. MVP. Yeah. Wait, not this. Okay. So pipeline builder, pipeline layout is mesh pipeline layout. Right, mesh pipeline, pipeline builder, build pipeline, device render pass. We're doing dynamic rendering, so I'm unsure how would it work. Yeah, they pass directly like this. Okay, I think it should be as easy as this, no? Light OBJ. Push constants. MVP object. Current frame. MVP constants. Then I can just pass mat4 as MVP. And then I do that now. About the matrix to the GPU via push constants. What does it need the current frame for? pipeline layout, render pipeline layout, and then MVP object constants. Something feels off. Mat4 MVP, and it is equal to mat4 mol and how is it exactly? UBO projection with UBO model, UBO view, and then the same thing again with UBO model. Push constants are used, but p push constants ranges set bk stage vertex bit. The Vulkan spec states if code type is bk shader, code type spur b extension, and if a push constant block is declared in a shader, then an element of p push constant ranges stage flags must match stage. bk create, okay. Do I need to set it here? P ranges. Interesting. What was it? Push constant count. And this would be equal to this thing. Wait, what? Okay, we don't get the previous error, and now we get this one. The bound shader was created with a push constant count of 1, which doesn't match the bound shader fragment bit. with push. What? I need to add this here too? I mean, it's like I'm not gonna use them, right? You set the correct flex? Yeah, it was shader stage bit. He used a different pipeline though. Maybe that's the problem. So the pipeline push constants, then adds this to the layout. Push constant. And then deletes it. Here he adds this. And finally in pipeline layout, he adds that as well. Mesh pipeline, pipeline builder, build pipeline. Then does about the same thing as we did, and then we push. Then only for bariotics should be. Yeah, but it was giving me the error that it should be set for fragment 2. The bound BK shader stage vertex bit shader was created with push constant range count of 1, which doesn't match the BK shader stage fragment bit shader created with push constant range count of 0. Old graphic shader objects must have been created with identical or identically defined push constant ranges. Okay, so I do it with what they say. You add it to fragment shader, pointer to it. But it's oops. Do I have to add this too, like fragment shader? Maybe. I don't think so. Remove from fragment shader. I know. The thing is, if I don't, it shows me that error. So, and when I do this, it tells me the same error. I think it's just because I'm not pushing it to the other draw call. I'll leave it like this and record command buffer. I'll push it before even beginning the command buffer. You should push right before draw call, and I should push twice, you think? Well, I'll do it here, and then I'll do it here. Just reuse most of it, except let's say this is on 5th, MVP is to this. Wait, Yeah, that's fine. This is in 2, 1, 25. There we go. Okay, push constants work. I don't get the error, but at least they work. Good. BK shader fragment. I mean, I already tried that vertex. Wait, never mind. Just ranges. So I add this, then I add fragment bit, then I push this to the second one, and then when creating the push constant here, I also do the same thing. Okay, now I'm getting a different error, it seems. Push constant is called with stage flags this, which is missing stage flags from overlapping BK push constant in BK pipeline layout. What? Maybe I can just do this. Oh, there we go. Okay, that was it. Only Toza is talking. That's depressing. Yeah, people shy here. Okay. MVP object. Okay, this makes no sense. This can be update push constants. Then the naming of this doesn't make sense either. Push constants. Sense. Yeah. And then here, instead of all of this, it would be a bit clearer to just add 4. Yes. And then this. Then you can just do that. And we can update everything else except projection. Well, look at, we don't need it either yet. Model is this. Do 10, 3. All right. So I'll keep the light OBJ. Met for position, or it's a back 3 actually. And this can be light OBJ position and I guess container position. And here we give it this. And then I'm gonna scale it a bit. Scale, model, takes a back 3, back 3, I don't know, 0.5 in all aspects, I guess. So they should be both in the middle. And we can init, or we can update per frame. Yeah. Current time, render dot light object position. Back 3. So how does this work? In Vulkan you have different coordinates now. So this is not x, y, z. Like this is not up. Let's put 0.5, 0.5, and this last one like that. Y, oh, minus Y is up, okay. So it's the same thing except that, what happened by the way? Can't stop it. Okay. Well. It takes over your PC, yeah. So then we do minus 0.5 and we can just sin x current time multiplied by 0.1. And then we move this a little bit back. Okay, not bad. It doesn't work. I think I need to update the render code or something. Or what? It's taking over. Yeah, 0.5. And then in that same push constant that we were setting before, we can set something like bool light. S light. And we can have many flags here. Maybe it could be a back something. Back 4. False, true. And if it is light, oh, I need to add the offset manually? I think I do. In constants is light is equal to true, then we give it light color, else whatever we got in the in color. In our case, it was spec 3 Something like that, yeah. So has a push constant buffer range with 0 to 92, which outside the push constant range. That match this stage. What? Push constants. So we have this to a slide, and it's 16 bits a line. Then we push normally. We tell it the size of it. I guess it's aligned, but not the size that it should be. Okay, there it is, but the thing we added didn't work. Also, the rotation should be 0. Rotate. Yeah, just don't rotate. That, and we scale it a bit more. Yeah, I'm not sure now. Why is it not taken true? So let's just take back 3, back 4, a slide, and check if 0 is equal to 1. It's easier, I guess. This is back 4, and then we set a slide to that. But that doesn't work either. What? Is it optimizing it, or what is wrong? Hey dude, what are you up to? Trying to push flags into my shader? My cables got messed up. So I set this to 0. I mean, I set the first thing to 0, that is equal. If it is equal to 1, I set this out color. I also set out color to in color. Switch them in position. This could be flags. That And then there's color, there's light, flags. There's constants, MVP is equal to MVP, flag 0 is equal to light. It's already in the other order. I'm gonna move this on top just to keep consistency. Then we update it twice. I mean, it's the same, no? It is moving, so it means that data is not corrupted. Yeah, it's spitting whatever it wants. Like, does it always enter here? Let's give it R. Oh, I think it's not using color, that's the problem. Dumb. In color, infrac color. Wait, what? It does out color, well, it takes infrac color, and it doesn't do anything with it. Oh, infrac color. Alright. That was the problem. You pictured it frame for each object, yeah. Shader? For which game, like Minecraft, or is it something like a game you made yourself? The latter. Okay, there we go. Can you do that? What? By the way, I do graphics designing 3D renders, so I can help you with something. In mind if I show you my work? Depends. I mean, if it is a promotion, no. If you just want to show to show, sure. But nothing changes, right? I am pushing constants. This is 0. Okay, how about I make it an int? And make sure it is equal to 1. I guess that's the problem. Oh, it says cannot convert layout column whatever float to I back 4. I guess that was the problem. I back 4. Okay, there we go. Good. Record command buffer. Model, I'll scale it a little bit down because it's too big. Problem was float was an ideal comparison, yeah. Okay. Well, that's all I wanted. And can I make it a bool or not? No. I don't know why it's so strict with that. GLSL. Wait, what does it say exactly? I saw the error. It was something layout. It disappeared. There it is. Cannot convert from layout temp high int to temp bool. Wrong operand types. No comparison exists. Blah blah blah. Not flexible at all, huh? Well, I'll just keep it int then. Okay, so we have that. Actually, I want to add some rotation when I move my keys. Where is event pool? Yeah, here. If key is this, wait, never mind, not this, but key is down. And this, SDL key right, left. First, let me check that those keys work. Okay, good. I press the left key to exit. So, let's say container position, here it is. What could this be? I mean, it needs to be like left, right, store position. I guess it can be an enum or rotation, I'm not sure. What is GLM rad? It's an F32. F32 container rotation. I should probably make a struct for this. I think I got the weirdest error of all Vulkan. What is it? Container rotation. is plus equal 1 or 0.1, 0.5, 0.2. This is minus. And then when rotating here is TSR, right? So if I rotate at the end, it should be good. So I want to rotate around the dy axis, 0, 1, 0, and then here glm rat render dot container rotation. I don't know what happened. I think I didn't save something. Oops, it needs to be on the Z. I think. And also it's rotating too little. Maybe 1. Maybe 2. Good. Wait, what is that? BK format RGBA unorm is different from BK image and then whatever that is format. Wait, what? What is that error if you have the same type? New event didn't find and replace. Oh. Spinning cube with Daft Punk around the world, 10-hour stream, 24-hour. You didn't find and replace RGB A8 to RGB BRGBA. Oh. Happens. This is why I use LSP to rename. But then the thing is, okay, you rename this, and you have to remember to save on here, because if not, it doesn't automatically save. Like maybe you change this to Quito, and then it will change the reference here, but this is in another file, right? So you have to save both this one and this one. You do the thing, you go here, and then do that again. Kind of the bad thing about new like you have to be saving all the time, because you don't know when it auto-saved and when it didn't. And there's like no, I mean, autosave plugins are good, but then they're a bit buggy, because sometimes I don't know, NeoVim is just not stable enough to have a autosave plugin that works well. But it was in the same file, yeah. I'm just saying, in the case that you use LSP rename, like even that is pretty bad. Like imagine you have, I don't know, 100 files, you would have to go through all of them that have the same reference and save them. Okay, push constants, very useful. How many hours of stream? We're 2 hours in. But we got the second cube working. Let's go. Oh god. You know, the thing is, instead of doing this, I should probably tell int is color is light instead, because we are gonna do some stuff on there anyways. What? Yeah. Oops. In must be qualified as flat in color undeclared identifier and assign. Okay. So first of all, I forgot to out color is equal to in color. Right. Should be something like that. And then this is infrac color, but I feel like it should be in color. Why would I change the name? Okay, there we go. And then the what is happening to my voice? In a slide is equal to 1, and it is equal to in color. And out color is in color. Out is light is this, and out is light is this. Am I getting any error? Frac 4 int must be qualified as flat in what? 4. Error int must be qualified as flat in. What does that mean? Only thing I like from VS Code is that it has good find and replace. You gotta do an ID for that, yeah. Using flat keyword, no interpolation is done. So every fragment generated during the rasterization for what the... Wait, what is that? In general case, there is no one-to-one mapping between vertex and fragment. By default, the associated data per vertex is interpolated across the primitive to generate the corresponding associated data per fragment, which is what smooth shading does. Using the flat keyword, no interpolation is done, so every fragment generated during the rasterization of that particular primitive will get the same data, which is what we want. Since primitives are usually defined by more than one vertex, this means that the data from only one vertex is used in that case. This is called the provoking vertex in OpenGL. You must declare them as flat in any case. In your specific example, the code means that each primitive can only have one material, which is defined with materiality and provoking vertex of each. Okay, yeah, makes sense. You pass in material and does whatever, and since it's an int, you have to make it flat so it doesn't interpolate. You can't interpolate integers? I guess you can. The thing is, we were not in the vertex shader. We were passing the same value over and over. Okay, we need the light to go a bit faster, you know. Here we go. Okay, let's continue. When we start to update these lighting shaders in the next chapters, the light source cube would be affected, and this is not what we want. We don't want the... okay, yeah, I mean, we don't want any lighting done on the lighting whatever. So we can just do out color is this and return, or discard. No, return. Yeah. And we can keep this the same way. Does that work? No. Cannot convert what? In color is back 3, color is back 3 too. Oh, my bad. My bad. That RGB? No, it was the out color. Hello, Ferro Block. Hello. So let's declare a global back3 variable that represents the light source location. We already did that. we then translate the light source to the light cube source position and scale it down before rendering it. Yeah. So it's TSR, translate, scale, and then rotate. We were doing it correctly. He uses the shader and does this. Okay. If it's not a 7-hour, 30-minute stream, I don't want it. We're gonna see. I'm drinking mate, so I'm energized. Though I can lie to you and say it's gonna be 7 hours and 30 minutes and just stop it when it's 7 hours 29 minutes and you're not gonna notice. Lighting in the real world is extremely complicated and depends on way too many factors, something we can't afford to calculate on the limited processing power we have. Lighting in OpenGL is therefore based on approximations of reality using simplified models that are much easier to process and look relatively similar. How about in Vulkan? Is it different? Never tried mate. Pretty good. And I'm going to be pissed, correct? Yeah, then I'll scam you like that. Mate, well, this is the mate that I'm drinking. I don't know if it's available anywhere else in the world apart from Argentina. But it's really good. And this was my breakfast. Not the entire bread, just 2 slices. Do you think so? You know, graphics programming? Yeah, I'm joking. Not entire bread, just 2 breads, yeah. Just plain bread, of course. It was really good bread, so I wanted to, get the taste. I didn't want to feel the taste of additional ingredients that add nothing. It was handmade by my father. The major building blocks of Phong lighting model consist of 3 components: ambient, diffuse, and specular lighting. Below you can see what these lighting components look like on their own and combined. Ambient, diffuse, specular combined. So ambient is the global light. Even when it's dark, it's still some light somewhere in the world. They burn a distant light, so objects are almost never completely dark. To simulate this, we use an ambient lighting constant that always gives the objects some color. Diffuse simulates the directional impact a light object has on an object. This is the most visual significant component of the lighting model. The more apart an object faces the light source, the brighter it becomes. Yes, and then specular simulates the bright spot of a light that appears on shiny objects. Specular highlights are more inclined to the color of the light than the color of the object. To create visually interesting scenes, we want to at least simulate these 3 components. We'll start with the simplest one, ambient lighting. But we already have that. Lighting usually does not come with a single light source, but many light sources scattered all around us. Even when they are not immediately visible, one of the properties of light is that it can scatter and bounce in many directions, reaching spots that aren't directly visible. Light can thus reflect on other surfaces and have an indirect impact on the light of an object. Algorithms that take this into consideration are called global illumination algorithms, but these are complicated and expensive to calculate. Yes. Hello, Benz. What's up? Finally, you come to the YouTube club and not the Twitch one. Aren't we cooler? Where are you hanging out with the other kids? You think SGA is overrated? Yeah. Yeah, someone was not reading the chat. I am today. I was too focused. Anyways, now this one has even less delay because I enabled lower delay. Adding ambient lighting to the scene is really easy when we take the light color, multiply it with a small constant ambient factor, multiply this with object's color, and use that as the fragment's color in the cube object's shader. Ambient strength, the light color, and you get that. So let's do it. We have color. Let's go step by step. So this is ambient strength, or ambient light shading. Yeah. Light color is defined here, and we do ambient multiplied by object color. Can it be like this? I think so. And it should look brownish. It looks too bright, but is that because we were doing the gamma correction thing? Yeah. We'll keep the gamma correction. Okay. If you now run the program, you'll notice the first stage of lighting is now successfully applied to the object. The object is quite dark, but not completely, since ambient lighting is applied. Note that the light cube is unaffected because we use a different shader. Well, we don't in our case, but we return early. Diffuse lighting. Ambient lighting by itself doesn't produce the most interesting results, but diffuse lighting, however, will start to give a significant visual impact on the objects. Diffuse lighting gives the object more brightness the closer its fragments are aligned to the light. Light rays from a light source. To give you a better understanding of diffuse lighting, take a look at the following image. Grab the normal, some vector math. To the left, we find the light source with the light ray targeted at a single fragment of our object. We need to measure at what angle the light ray touches the fragment. If the light ray is perpendicular to the object's surface, the light has the greatest impact. To measure the angle between the light ray and the fragment, we use something called normal vector. What is perpendicular? Like it's right in front? I guess. Or is it by the side? Right, so here's our eye, and it's perpendicular with the same angle. Okay. To measure the angle between the light ray and the fragment, we use something called a normal vector. That is a vector perpendicular to the fragment's surface, here depicted as a yellow arrow. We'll get to that later. The angle between the two vectors can then easily be calculated with the dot product. You may remember from transformations chapter that lower the angle between two unit vectors, the more the dot product is inclined towards a value of 1. When the angle between both vectors is 90 degrees, the dot product becomes 0. The same applies to 0. The larger 0 becomes, the less of an impact the light should have on the fragment color. Right. English math is hard. Yes, Amod. Learning basic physics stream. You always learn physics when doing lighting. It's like you do PBR, you do whatever, you're always gonna learn some physics. 0. Know that only the cosine of the angle between both vectors we will work with unit vectors, vector of length 1. So we need to make sure all vectors are normalized, otherwise the dot product becomes more than just the cosine. So it goes from -1 to 1 by default. Are we setting the normals? Oh, please tell me yes. Vertex. Oh, we don't need to. Oh, we do need to. Damn. Position, color, text coordinates. Math cannot be English. Yes, but it can be British. A normal vector is a unit vector that is perpendicular to the surface of a vertex. Since a vertex by itself has no surface, So what do we need to calculate diffuse lighting? Normal vector, the directed light ray, a direction vector that is the difference vector between light's position and the fragment position. So we can pass this through UVO, and normal will have to update the vertex. A normal vector is a unit vector that is perpendicular to the surface of a vertex. Since a vertex by itself has no surface, it's just a single point in space, we retrieve a normal vector by using its surrounding vertices to figure out the surface of the vertex. We can use a little trick to calculate the normal vectors for all the cube vertices by using the cross product. But since 3D cube is not a complicated shape, we can simply manually add them to the vertex data. Yeah. The updated vertex data array can be found here. Try to visualize that the normals are indeed vector perpendicular to each plane surface. A cube consists of 6 planes. So how do we do this? We have position, color. Let's add a new one. He's taking a pos and a normal. I guess it would make sense to keep it like that. Position, normals, normal. Color, text chord. Okay. So how do we do this? Load model. Then we do normal. I have a tactic. Can you update this to use normals as the second param? Here is how it should be. Yoink, and this are my this is my vertex struct. If I would hear it in my language, native, then I would know without thinking. Where are you from, Toza, by the way? Somewhere in EU. Okay. Keeping it mysterious. Yoink. Front face, back face, left face, right face, bottom face, and top face. I'll keep it like that. Now we should have the same amount, so this is 16, and it should be... Okay, good. Imagine having to type all that. Yeah, I wasn't going to. Okay. And then vertices. I just use it for repetitive stuff like that, or when I need to understand some concept. It's pretty good at that. Offset. Offset off. Here it is. So we have this. Right. All of this needs to go up by 1. Okay, not like that. Like that. This is location 2, 1. This is location 2, this is location 3. And that would be what is normal? So we have position, normal, color, and text code at the end. This is RGB, 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 RGB. I mean RG. 0, 1, 2, 3, and I feel like that should be it, and I shouldn't have to set anything else. Okay, it means it works because it's getting the text chords as the color, I think. I don't know. In normal. And we are doing position in normal, in color, in text chord, yeah. And if we do just that, it should stay the same. Okay, what happened? Vertex shader uses input as location 3, but it is not provided in this. What is that? Set vertex input and then input binding. It's this. Binding is 0, stride is off with this. Is it because... Oh, my bad. Okay. They do all of that, and then we do out color, out text chord, out is light. I feel like it should be like this. This back 3. Actually, it shouldn't even be like this. It should be like this. 1, 2, and 3. Out normal. In normal. Out color, in color, out normal, out in normal, out text chord, in text chord, out is light. Yes. And then this should be in color, that is good. Then here 2 and 3 in back 3 in normal. Then text chord and at the end that. And we should have no changes. Calculating the diffuse color. We need to send the light position as an uniform. So let's just do back 3 light position. Yeah. We can do that now. I should pass it as back 4 actually. Yeah, probably. Then uniform, what is this here? Back 4 light position, push constants, light position is equal to light vendor dot light position, And this is S? No, it's not S. How do we convert it? I think you can do back 4 or glms back 4. Yeah. Okay, and then we do that. Frag position normal, and we just take it on the vertex now. We have the normal vector for each vertex, but we still need the light position vector and fragment position vector. Since light position is a single static variable, I can declare it as a uniform in the fragment shader. And then update the uniform in the render loop or outside since it doesn't change per frame. We use the light position vector declared in the previous chapter as the location of the diffuse light source. Just need to add swapchain recreation, and my C rewrite will be good enough to start loading models. Wait, you're resizing it? I think I should remove the resize code, because it just makes everything buggier, and it changes my entire screen whenever I execute. Wait, no, it's just in my case. Like, I do this, and you see that it starts in the middle and then it moves to the right, but that's my window manager. I prefer it to stay like in the middle of the screen and it's not movable, not resizable. It's not that bad though. Yeah, I mean, it's the same thing. It's a recreate swapchain. You just need all of this. But you already have most of the code except the cleanup and the wait and minimized. But then you have to wait idle. I mean, this is the most expensive part now. We need is the actual fragment position. We are going to do all the lighting calculations in world space, so we want a vertex position that is in world space first. We can accomplish this by multiplying the vertex position attribute with the model matrix only. Oh, but we're not passing the model matrix, we're passing MVP. I guess I'm gonna have to multiply it before sending it. Yeah. Alright, I need to free all of this. Yeah, I mean, there's some cleanup to do with resizing. So before I send it, I transform this, which is APOS. What is APOS? It's the light position? No. Oh, it's the position of the vert. Yeah, I don't know, I guess. Word naming, yeah, OpenGL tutorial is pretty bad naming for shaders. Like frac position, normal, but is it in, is it out? Then why is it A? Why is it not a B? And then it takes in frac position. Well, I guess we can't pass MVP, but we can pass BP and model, right? MVP. Projection and view, and then model, I guess. Because it is in this order, right? So, yeah, I think it's fine. Mat4s. I mean, at this point, maybe just pass in everything. Anyways, my GPU should be able to handle MVP. And push constants. Why not C? What do you mean? Mat4s. Okay, I don't know what is gonna happen. 128 and this. Zig user, by the way. Why not? C was with naming. Oh, right. Didn't get it. Yeah, it's very inconsistent. It's just to like get it out of the way. I don't know. Hyperland user, by the way, and Arch Linux user, by the way. Nixos user, by the way. Then someone comes and says plan 9 user, by the way. Assembly user, by the way. Windows 11 user, by the way. What do you mean this is a distribution based on Linux? It just looks like Windows a lot. It's you. It's the most based distro on the planet available right now. What? Oops. In constants. Oh, what happened? Wait, how was I doing it before? SRC shaders. I'm multiplying it wrong, right? I already feel it. It's a projection view model. Oops. Got. Okay. And then they create frag position like that. Back 3 model multiplied by a pos, which in our color is in position. Okay. And of course, we need to set the out value again. Back 3, back 3, yeah. Out frag position 4. I feel like it should be like this. Yeah. In order of biggest to lowest. So out color in normal frag position. In frag position, and that is it. And I will just multiply it by this so it doesn't get optimized and some weird bug happens. Okay, it doesn't work. It doesn't work because I'm not sure. Out is light. 1, 3, 4, 5. Okay, my bad. 3, 4. Okay, it's still doesn't work. Okay. What is the problem? Fragment declared input allocation for component. Yeah. And what is the problem? Out color, out normal, out frag pos. All back 3, text court 2, and out is light as well. An int. And then we put everything on there. What? What am I doing wrong? Model multiplied by in position. And fill it with 1. Model undeclared, undefined. Oh, I'm dumb. In constants dot. Okay, first of all, okay, that should work. Second of all, do I need to do that? Yeah. And why does it put this thing below when I do that? In Yu-Gi-Oh! well, whatever. This invariable will be interpolated from 3 world position vectors of the triangle to form the frag position vector that is per fragment world position. Now that all the required variables are set, we can start the lighting calculations. Wait, light position is used on the fragment shader? Oh, okay. This is getting more and more messy. Back for light position. I'll put it first. In constants. Out light position. Okay, we either do pos or position. In pos. Same in here. Out light pos. One, two, three, 4, 5. Wait. Yeah. Okay. What are you saying? Have you guys tried Warp? I ditched VS Code for this thing. It's another AI editor. It's more AI terminal. You already know the speech productivity booster. What is that? Warp AI terminal. Oh. So you just tell it to do something and it executes the command, no? Okay. This in barrel will be interpolated from 3 world position vectors, yeah. The first thing we need to calculate is the direction vector between the light source and the fragment position. From the previous section, we know that the light direction vector is the difference vector between the light position vector and the fragment position vector. As you may remember from transformations chapter, we can easily calculate this difference by subtracting both vectors from each other. Yeah, as I said, vector math. You also want to make sure that all the relevant vectors end up as unit vectors, so we can normalize both the normal and resulting direction vector. And this is because the normals go from -1 to 1. Yeah, that's what I expected. So this is ambient, and then they do normalize normal. Okay, again a little bit interesting naming. In normal, model normal, light direction, in light position, and in frac position. When calculating lighting, we usually do not care about the magnitude of a vector or their position. We only care about their direction. Because we only care about their direction, almost all the calculations are done with unit vectors, since it simplifies most calculations like dot product. So when doing lighting calculations, make sure you always normalize the relevant vectors to ensure they are actual unit vectors. Forgetting to normalize a vector is a popular mistake, I remember. Next, we need to calculate the diffuse impact of the light on the current fragment by taking the dot product between norm and light there vectors. The resultant value is then multiplied with the light's color to get the diffuse component, resulting in darker diffuse component the greater the angle between both vectors. Oops, what did I do? Control R. So this is the their diff model normal, light direction multiplied by light color. Yeah, and then I'm guessing, okay, so this is ambient, this is already diffuse. When do we add that? If the angle between both vectors is greater than 90 degrees, then the result of the dot product will actually become negative, and we end up with a negative diffuse component. For that reason, we used the max function that returns the highest of both its parameter to make sure the diffuse component and thus the colors never become negative. Lighting for negative colors is not really defined, so it's best to stay away from that unless you are one of those eccentric artists. Now that we have both an ambient and diffuse component, we add both colors to each other and then multiply the result with the color of the object and the color of the object to get the resulting fragment output color. So result is ambient plus diffuse. Right. Okay, here we do this. Back 3, color is equal to this. Color is equal to this in color, because we never edited after that, no? Yeah. It's a bit confusing. Wait, what happened? 29. In light position, in frac position. Yeah, what about that? Light direction, what? Wrong operand types. No operation minus exists that takes a left-hand operator of type layout location 0 smooth and high 4-component vector float, and a right operand of type layout location 3 smooth in high 3-component vector float, or there's no acceptable conversions. But what do you mean this is the same thing? This is back 3 and this is back 3. Oh, I mean, it's saying about this. This is back 4. Oh, my bad. RGB. Yeah, I am sending it like that because it was... What? Okay, that definitely shouldn't be happening, right? Let's make this back 3, 0. And then let's multiply it by the in color. Is it the gamma correction? No. We're normalizing here. It's like almost correct, but I feel like it's overflowing somewhere, right? Is it because of the light color that is 1? Source code is here if you're stuck. .ps. This. We're doing MVP. Frag position is model multiplied by APOS. This is a 1. Push constant. Oops, where is it? Record command buffer and then here. This should be 1.0. Is that it? Okay. So it grabs APOS, which is the place that we're on right now. Oh, yeah, it's not related. Anyways, it would be doing it by RGB only. Okay. So let's go step by step. First, it gets the frag position here. Which is the model multiplied by the position that we are on right now. And is 1.0f. Then we give it the normal. In our case, we have to give all of this, but it doesn't change. Oh, no, never mind. Maybe it's something that should be interpolating and it's not. We'll see. Then, of course, projection view model. Oh. Right. Okay. It's interesting how that does. Well, yeah, it shouldn't change anything. So frag position grabs the model, multiplies it by back 4, impulse adds 1, does projection and view, and sends this out. as GL position and here. Then here it takes in all of this. Ambient strength. It's a 0.1 F. Light color is this, but what is it exactly? Light color 1F, and this is curl. I miss OpenGL uniforms. Okay, then normalize in normal. Is this what it's not interpolating, maybe? No, never mind, because I'm sending it like this. I'm not sure. Normalizing here anyways. Within normal, then light direction, normalize in light position, RGB, since it was a back 4 in our case, minus frag position. That's the light direction. Then diffuse is max dot model normal by light direction 0.0. Finally, diffuse is diffuse multiplied by light color, ambient plus diffuse, and then object color, which in our case is in color. And then we calculate this and return result to 1. Maybe it's because I'm using y as if it was plus y in the math. Could that be a thing? So when I normalize, I'm not sure. Let me move the light position in front of us so we can see better. So that would be wait, 0.5 F. Is it that? What? There we go. And I guess this should be minus like we had it before. And let's push it a bit further away, just a tiny bit. So there it's at almost the same height. And it should be a bit further away. In which direction is it going? Yeah. It's just going too slow. DTF. You know, it kind of looks like the coordinates are the problem, because you see how it's not lighting. Yeah. How does it look here? Okay, well, that's interesting. So, let me think. First of all, the weird thing is, wait, this is going left to right. But this is Y. This is X, this is Z. It's almost like Y is acting as Z. And this is acting as Y. And X is acting normal, right? It's moving in the other space. Is it like the angle that we're looking at? This, maybe? Maybe this cube is rotated? Rotate. Here it switches this to -1. I'm not sure. Well, I'm not sure. diffuse shader in Vulkan. Is there an example? Even while rotating the z-axis, are you rotating the mesh itself or the view of the mesh? Which matrix are you manipulating? Are you sure you're manipulating the right one? This is the problem we have, right? We rotate it and it doesn't change. Diffuse light plus equals power multiplied by cos angle of indices. Yeah, but that's already doing Phong, no? They do projection view model. Yeah, they do this and then they give the model matrix. Direction to light is this. And I pasted in this. You can send it on my Discord. It's on the description. Because I don't know why it doesn't let me allow links. Like I don't have moderator activity, nothing. Oh wait. Can you send it now? I think I enabled something because it said some messages such as potential spam may not be visible. Now all messages are visible. Push transform is okay, so this is the same that we have. Then normalize, normal world space, model matrix multiplied by normal. Is this Phong shading? Can you try sending the link and tell me if it works? Again? Or before? Above this code? Okay, paste bin.com/this. Sent again. Yeah, it doesn't show. Oh well. But it's for multiple lights, yeah, it's fine. Global UVO, point light, model matrix, normal matrix. This is BERT? No, this is fragment. Diffuse lighting, it's ambient light, XYZ multiplied by UBO, ambient light, W, what? Specular light, surface normal. You don't seem to be doing anything weird with coordinates though. Against the bird, sure. But it shouldn't change. Public paste. Make $900 instantly, really. Light intensity is max dot normal world space. This shader code is literally the same. Normal world space. I mean, he's doing it on the fragment shader. I can remove this. But it's the same. Max dot normal world and direction light 0, and then he does light intensity multiplied by back 3. The thing is, when you do this calculation here, this is Gurat, no? I feel like. I remember mine was from one of YouTube tutorials, I remember her name. Yeah, I mean, don't worry. I have to struggle through this to realize what is wrong. Without too much work, you can translate it to Vulkan. The main thing you need to do in Vulkan is generate the normal vectors. Send the material color reflection of the object and color and intensity of the light source, which is optional because they can be hard coded in the shader. As long as you use GLSL shaders. Have vertex normals in your vertex attributes. Maybe my vertex attributes are wrong. Like GPT generated the wrong ones. It sounds like something that could happen. Which are the normals? This one's no. Yeah. So minus 0.5, minus 0.5, minus 0.5, 0, 0, 1. Okay, this phase is all this one. Next phase, front phase, minus, yeah. This is all positive 1 and 0. Then this one is minus 1. Right phase is 1. This is right phase, no? Yeah. Left phase is minus 1. Oops. But no. Wait, I mean, left phase? Zero 0.5, 0.5, 0.5, 1. I mean, it's because they have it in a different order, right? They have the right one before the left one, but it's the same, I think. 0.5, 0.5, 0.5, 1, 0, 0. Yep. Then this one minus 0.5 minus 0.5. Where is it? Now there needs to be something wrong with the normals. Are my normals correct? Original OpenGL code. Vulkan code. Upload a light direction in view space along with a normal matrix to a uniform buffer. Normal matrices are simply transpose inverse. Okay, so you can calculate it on the thing itself, but since we're using cubes, we don't need that. Multiply the normal with vertex normal in the vertex shader and send the result to the fragment shader for per pixel lighting. This is the in fragment. In the fragment shader, calculate the inversion term by calculating a scalar product of the light direction and the vertex normal dot normal light. Of course, normalized before and getting the. You can now use the inversion term as a coefficient for your lighting. For example, light color multiplied by material color multiplied by Lambert. Isn't it plus? Looking at your code, I see some issues in the problem stems that you're using index geometry with shared vertices. Yeah, something was wrong with the normals. Oh god. Can never trust AI. Okay, this is ugly. What? And then what happened? Oh. He changed that to cube. Sure. Better naming. There we go. I think I'll need to abstract my code a little because now it's one blob in main function, yeah. That happens. Okay, I mean, this is working, but it's not working with the rotations. I think it's something related to the shader, but we just didn't do it on the tutorial yet. Okay, good. I was scared to use different math because of the difference. But it shouldn't, right? Because we're not doing anything specific with y coordinates. We're like multiplying vertices and whatever. You know, about abstracting, I'm not sure how to do it in my case. I've been thinking it for some time. I'm still not really sure how should I do it. I have a lot of dynamic values. Like for example, these two are dynamic and depend per shader. Texture, image view, and texture sampler can all be created in one function. Vertex buffer is dynamic, index buffer is dynamic, create uniform buffers is dynamic. Descriptor pool is not dynamic. Oh, never mind, is it? Yeah, it is dynamic, because it depends on the sampler and the uniform buffer. Well, almost. It's like every single mesh you have is gonna have at least one texture. And then create descriptor sets is based on that. Yep, it will be hard. Like making something like Vulkan does for dynamic, like struct with data and passing into functions. I mean, I'm not sure. I'm not sure if I should do only initialization in my init function and like then I have to see what is connected to each one. Like, can I put this on here and do all of this dynamic stuff right after initialization? Are this able to be here? Because if not, then well, I have to do initialization. Then I could create shaders and pass the descriptors. Like it could be something like, yeah, for example, this, like, it's messy. I have to do load model because we already need it when I am creating the vertex buffer, right? So it needs to be before the init renderer, but it shouldn't be like that. Load model should be below here. And I should be able to put my model and like, it should give me something like model. Maybe there's a vector of models. I don't know how I would abstract it. It's difficult. But I was thinking it could be something like, I don't know, load shader. You pass in the shader value, it returns something like shader, and you also pass the descriptor sets here, because you can use push descriptors now. So under the hood it creates them on the same descriptor pool, so that is abstracted. And I guess when you create your model, it should create the vertices and whatever else there too. I don't know if there's something like push vertices. But I'm sure I can figure something out like that makes it pretty dynamic. I want it as dynamic as possible, kind of like if I was using OpenGL, because I don't really care about performance, right? I just want my simple Vulkan render where I don't have to create my pipelines, like all the pipelines at the start. It's hardest part, yeah. The abstractions are the hardest part. That's why I was thinking maybe I could abstract it very simply, kind of like how SDL3 GPU does it. What about all the threads? No, I'm not using the multiple threads. Maybe for input, like that's it. Then for recording command buffers, no. No. At least for now, I'm not. I don't see the purpose. Yeah, you see they come on init. Oh, but this is this already has some boilerplate under the hood. I think it creates the device and other basic stuff. Loads the shaders, then creates the pipeline based on this. I would need something similar because I am like dynamically creating the pipeline, quote unquote. But I would like better defaults, right? So this are really good defaults, except this one. Like I always want triangle list, right? Just set that as default, and if I want to change it, just change it to whatever else. Like authorization and whatever. Like, yeah, this for example. Why do I have to set fill mode to fill, and why is it not this by default? Like I guess it's lines, so wireframe. I want good default so I don't have to do stuff like this, and when I have to do it, I just change it manually. The 0 value needs to be useful, like that's my plan. And then this, for descriptors, this is really simple, I like this. This is what I want. Yeah, like constructors, because you make wireframe, yeah. And then they create another one. This one is fill mode line. Maybe it is by default fill, and they're showing this to make it a little bit more explicit. Because they created the line pipeline and the fill pipeline, so I guess it makes sense. Then they released the GPU shaders, and then when they're drawing, like that's literally it. That's so simple. That's so good. I mean, I don't like the step of creating the pipeline. I think that should not be a thing. Like I should be able to bind whatever. Well, I don't know. This isn't that hard to make. Like this entire thing isn't that hard to make. Then you acquire a GPU command buffer. Wait, acquire GPU swap chain texture. So this is a defense, I'm guessing. No. Where are defenses? Maybe on submit. I'm not sure how it works under the hood. So if swap chain texture does not equal null, right? So this is acquire image index, right? And it gives you the index, and I don't know how many they have under the hood, probably 2 or 3. Or you can set it. Then you have the store up, load up, clear color texture. You set that all manually. Render pass, GPU graphics pipeline. You have to bind it. Small viewport. So this is viewport and scissors. You can set dynamically. And then draw GPU primitives. And render pass and submit the command buffer. I feel like I could do something like this instead. And maybe I use pipelines. It's very complex to implement, yes, but the system that I was thinking before, it's maybe too complex. Or I'm not sure. I'm thinking either I do it low level like this, or I do it like extremely high level. So I just have something like mesh draw, and I give it a model, or model draw rather. And I give it a model, and under the hood it has meshes and the textures and whatever. And then I have like an array of that, and that's it. But I feel like that's too high level. Like relive. Yeah, like it has to be very simple if I want to do it like that. But I don't feel like it works for Vulkan, since there's so much upfront state that you have to set. Though I'm thinking maybe I can like simulate pipeline create info using dynamic pipelines like I was doing before. It would simplify a lot doing this since it's more dynamic state. Not sure. I'm getting too ahead of myself. I'll first suffer a little bit with this and maybe I get some genius idea on how to abstract it better. Yeah, finish lighting first. That's true. Yeah, so we already have that. One last thing. In the previous section, we passed the normal vector directly from the vertex shader to the fragment shader. Yeah, about that, I should probably make the push constant available both in the fragment and vertex, because I'm passing too much from one place to another. So push constants. Yeah. So it should all stay the same pretty much, and then here I need to take this in. Right? And then I wouldn't need light position, I wouldn't need flags. I wouldn't need... Okay, that's it. And now int is light can be in constants dot flags 0 boom, and I can just replace that. Next thing, color good, yes. Light position, this is again in constants. Why is it constants? I'll keep it like this for now. Light pos. Model normal. And color, okay, and that's it. And then on the other shader, we don't know, we no longer need this, we no longer need this, we no longer need, that's it. Oops. Gotta go, maybe join later. Alright. See ya. So out color and that. And out frag, of course. Of course. Maybe you can do all of this at the end, right? Something has to break because it always does. It's insane the amount of undefined behavior that is possible in Vulkan. Like, there's so much undefined behavior, but it still works, right? In some GPUs. You can get like 400 validation errors and it still works fine. I don't know if like driver creators for Vulkan are crazy good, or they are just not validating. Well, of course they are not validating anything at all. Command push constants is called width, stage flags, stage vertex bit, offset size, which is missing stage flags from overlapping push constant range in BK pipeline layout, blah blah blah. Stage flags, this, offset 0. For each byte in the range specified by an offset and size, and for each push constant range that overlaps that byte, stage flags must include all stages that push constant range. So it's basically complaining that I'm not passing an offset and I'm passing the same push constant to both. Now the thing is, why am I getting that error? My shader is compiled well, right? Yeah. My shaders have no errors. And I guess it's push constants not being able to do that. By the way, what? Size. Okay. Push constants. In BK guide, they said that they were able to use both of them for both vertex shader and fragment shader, but it doesn't say how. It doesn't even show the code. This is on bird, and that's it. In fragment and vertex shader. Specifies the stage flags, yes. Or a combination, offset and size of the push constants data accessible by the stage. How about if I want both stages to access the same data? Can I put some push constant on vertex shader and one on push constants work in ranges? You can push some data in vertex shader, then push another one to fragment shader by an offset. Yes. And then they do PC data offset is 16. Size of is that, and then I mean, I could create push constant for fragment and push constant for vertex, but I'm not a fan. Yes, this is what I want, but no one... No one says how to. Offset, size. Okay. Where am I reading this from? From guide. So they have push constant STD 430 uniform PC. When you look at this PRB, parts of this are similar. Okay. We put both shader and fragment. Then they do that. Push constant and oh, that's the thing. Push constant. When we updated the push constant. Record command buffer here. That's the thing. Fragment. Does that work? Oh, okay. Okay. Also, what happens if I remove this? It's probably gonna tell me that oh. Right, because we're not updating them, right? Oh no, we are, but we can just remove that. Oops, what? Save this, save this, save this. Okay. And if you don't do that, you can use this normally, right? Yeah, look at that. Well, that's really interesting. Flex, light pulse, and that's it. Good. Push constants. Let's keep the naming consistent. All right. Yeah. Bind pipeline B, push constant. Bind pipeline A, compatible with layout 0. Oh, okay. If it is non-compatible, then it fails. Well, the validation layer fails. Yep. Pipeline, push constants, offset 0, size 16, value. That is if you want to have different offsets. But that would be in different pipelines? No. Well, whatever. However, the calculations in the fragment shader are done in world space. So Shouldn't we transform the normal vectors to world space coordinates as well? Normal vectors directly from the vertex shader to the fragment shader. Yeah, that was on here. First of all, normal vectors are only direction vectors and do not represent a specific position in space. Oh, yeah, that makes sense. I mean, because it doesn't matter, it's like the direction only. Second, normal vectors do not have a homogeneous coordinate, the W component of a vertex position. This means that translations should not have any effect on the normal vectors. So if we want to multiply the normal vectors with a model matrix, we want to remove the translation part of the matrix by taking the upper weight. If we want to multiply the normal vectors with a model matrix, which is what we were doing, we want to remove the translation part of the matrix by taking the upper left 3x3 matrix of the model matrix. Now that we could also set the W component of the normal vector to 0 and multiply with the 4x4 matrix. Second, if the model matrix would perform a non-uniform scale, the vertices would be changed in such a way that the normal vector is not perpendicular to the surface anymore. In a non-uniform scale, the following image shows the effect such a model matrix with non-uniform scaling has a normal vector. Right? Whenever we apply a non-uniform scale, note a uniform scale only changes the normal magnitude and its direction, which is easily fixed by normalizing it. Their normal vectors are not perpendicular to the corresponding surface anymore, which distorts the lighting. The trick of fixing this behavior is to use a different model matrix specifically tailored for normal vectors. This matrix is called the normal matrix and uses a few linear algebraic operations to remove the effect of wrongly scaling the normal vectors. If you want to know how this matrix is calculated, it's just following the following article. So they added W from the 3x3 matrix, transpose inverse. I just want to see what it looks like. Oh, I thought they were going to do it more visually. But I think they just do the 3 upper part. Is defined as transpose of the inverse of the upper left. Yeah, that's what I thought. Part of the model matrix. That's a mouthful. The transpose of the inverse of the upper left 3x3 part of the model matrix. That's a mouthful, and if you don't really understand what that means, don't worry. We haven't discussed inverse and transpose matrices yet. I'm not sure what it does either. Note that most resources define normal matrix as derived from the model view matrix, but since we are working in the world space and not in a view space, we will derive it from the model matrix. In the vertex shader, we can generate the normal matrix by using the inverse and transpose functions in the vertex shader that work in any matrix type. Now that we can cast the matrix to 3x3 matrix to ensure it loses its translation properties, and that it can multiply with vec3 normal vector. Well, are we transforming it? I think we are. Model. Yeah, we are translating it. So that's where it comes from. And this is calculated where? model, that becomes normal. Is that it? I think it isn't because it was taking this naming. I hate it. Does it use a normal here and already passes the fragment? Okay. So normal is a normal and we are passing that as normal. In our case, it would be out normal. Okay. So we transpose and inverse the model and do it by in normal. Does that work? Okay, yeah. And now when we move it, it does actually work. Because it removes the translation part. Also the operations for shaders, so whenever possible try to avoid doing inverse operations since they have to be done on each vertex of your scene. For learning purposes this is fine, but for an efficient application you'll likely want to calculate the normal matrix on the CPU and send it to the shaders via uniform before drawing it, just like the model matrix. Okay. Yeah, that makes sense, because like why would you do it for every single vertex? In the diffuse lighting section, the lighting was fine because we didn't do any scaling on the object, so there was not really a need to use a normal matrix, and we could have just multiplied the normals with the model matrix. What operating system? Does this tell you anything? I should close this. It's essential you multiply your normal vectors with a normal matrix. Okay. And let me stretch for a second. If you're not exhausted already, I kind of am, we can start finishing the font lighting model by adding specular highlights. Similar to diffuse lighting, specular lighting is based on the light's direction vector and object's normal vectors. But this time, it is also based on the view direction, example, from what direction the player is looking at the fragment. Specular lighting is based on the reflective properties of surface. If we think of this object surface as a mirror, the specular lighting is the strongest wherever we would see the light reflected on the surface. You can see this effect in the following image. So this is when it's perpendicular. Wait. This is the strongest one, and then this one takes a bit less. We calculate a reflection vector by reflecting the light direction around the normal vector. Then we calculate the angular distance between the reflection vector and the view vector. The closer the angle between them, the greater the impact of the specular light. So the resulting effect is that we see a bit of a highlight when we are looking at the light's direction reflected via the surface. The view vector is one extra variable we need for specular lighting, which can calculate using the viewer's world space position and the fragment position. Then we calculate the specular intensity, multiplying this with the light color and add this to the ambient and diffuse components. We choose to do the lighting calculations in world space, but most people tend to prefer doing lighting in view space. An advantage of view space is that the viewer's position is always at 0, 0, 0. So you already got the position of the viewer for free. However, I find calculated lighting in world space more intuitive for learning purposes. If you still want to calculate lighting in view space, you want to transform all the relevant vectors with the view matrix as well. Don't forget to change the normal matrix too. Yeah, you would need to multiply it. View and model, right? To get the world coordinates of the viewer, we simply take the position vector of the camera object, which is the viewer, of course. So let's add another uniform to the fragment shader and pass the camera position vector to the shader. Now our camera position is going to be at 0 for now, because I don't want to move it. Like it is at, where is it? Is this it? Look at, this is up, center, and I. Yeah, I think this is the default one. So let's assume that we are at back 3 camera position, and it's equal to back 3 0. Does that compile? Yeah, no problem. Okay, make it camera pos. Specular strength 0.5. This would depend on the material. Specular. We would set this to 1.0f. We would get a really bright specular component, which is a bit too much for a Kroll cube. In the next chapter we will talk about properly setting all of these lighting intensities and how they affect the objects. Next we calculate the view direction vector and the corresponding reflect vector along the normal axis. View direction. So instead of camera position, view position. Minus frag. What is it? Infrag? Yeah. And then light direction, we do it by norm, which was our model normal. Reflected direction. From the light source towards the fragment position, but the light their vector is currently pointing the other way around, from the fragment towards the light source. This depends on the order of subtraction earlier on when we calculated the light their vector. To make sure we get the correct reflect vector, we reverse its direction by negating the light direction vector first. The second argument expects a normal vector, so we supply the normalized norm vector. Why do you call it norm? Then what's left to do is actually calculate the specular component. This is accomplished with the following formula. Oops, can't copy today. And this is 32, 64, 128. This is roughness. No, shininess. We first calculate the dot product between the view direction and the reflect direction and make sure it's not negative. Then raise it to the power of 32. This value is the shininess value of the highlighting. The higher the shininess value an object, the more it properly reflects the light instead of scattering it all around. And thus, the smaller the light becomes. Below you can see an image that shows the pressure impact of different shininess values. But you don't want the specular component to be too distracting, so we keep the exponent at 32. We can make a function later. And then we sum them all up. All up of S. All up in this. Should look something like that. Okay, I think we have the spec in the wrong. Yeah. Is it this? Okay. I think that's it. And let's do 128 to notice the effect. I couldn't get to see it. Oh, there it is. I was going to the left. Is that how it works? I mean, the thing is we have the camera on 0, 0, so it's a bit weird, right? So when I add the camera, it will be better. Yeah, but that's as good as it gets. I'll leave it like this. Yeah. You can find the complete source code of the application. In the early days of lighting shaders, developers used to implement the Funk shading lighting model in the vertex shader. The advantage of doing lighting in the vertex shader is that it is a lot more efficient since there is generally a lot less vertices compared to fragments. Yeah, I mean, you have like 12 times 99%, 99x more points in the fragment shader. So the expensive lighting calculations are done less frequently. However, the resulting color value in the vertex shader is resulting lighting color of that vertex only, and the color values of the surrounding fragments are the result of the interpolated lighting colors. So it's like flat shading, but you know, for the vertice. So it looks decent on circles, but it probably wouldn't on a cube. Was not very realistic unless the large amount of vertices were used. Yeah, I mean, and there's a lot of vertices here already. So imagine. It's interesting because you can see each of the vertices. You see it like on the middle, it's the most bright, then like that, like that, like that, and more. By now you should be starting to see how powerful shaders are. With little information, shaders are able to calculate how lighting affects the fragment colors for all objects. In the next chapters, we'll be delving much deeper into what we can do with a lighting model. And it does try to move the lighting source around the scene using time, either sin or cos. Well, we are already doing that. How do they do it? Yeah, multiply by 2. Play around the different ambient, diffuse, and specular strengths and see how they impact the result. We already tried 128. Do func shading in view space instead of world space. I'm not sure how you do that. So light position is view multiplied by this, and we need to do that in the vertex. Extra variable, since we need light position and view space and calculate it in the vertex shader. And then, yeah, I think we should do that instead of passing in the light position to the fragment shader. So this is view. Wait, no. We have to do light position is light position back 3 and yeah, I don't know what else. It was multiplied by view, and that's all I remember. I think we have to transform it into back 4. Wait, where is it? What am I looking at? Here. View. Oh. Yeah, close. Back 4, light position, 1.OF. So that stays the same. We send in this. Yeah. And now light position here, 3, 4. In light pos. So and we no longer need the light direction. I mean, we no longer need the view direction. Position, my bad. Damn. So what are we using from here? Model? No. View? No. Projection? No. Light position? No. Flex only. Well, maybe not as necessary then. Can just pass that from vertex. So light direction is already, oh wait, I'm doing something weird here. So light position is already back 4, right? Thank God I noticed. Then light position minus frag position. Direction difference, diffuse. View direction is already in fracpos. And light direction, model normal, nothing else changes. Oops. In light pulse is the third one. Yeah, that's correct. We're doing view multiplied by light position, which is back 4 in this case. We send in that as back 3, take in light position. View direction is now in fracpos. Fracpos does not change now. Oh wait. Right. Normal stays like that. Frac position. This is that. And we no longer do it with APOS. I mean, we no longer do it with this. Model. View model in APOS. Okay, yeah, that's what I was missing. And then we do proj, view, and model, since we are no longer multiplying it with fracpos. Okay, what happened? APOS. Yeah, something like that. We don't even use text code, so I don't even know what I'm sending it for. Normal is transpose. Oh, we need more comments, man. Light position multiplied by light position. Yeah, that's it. That, and we can keep it at 16. No? Yeah. Good. Okay. We got specular lighting and diffuse, so Phong in general. This one is very simple. And this is the type of stuff I should take from the UBO. Okay, well, it's enough for now. I'll continue this later. I'm already kind of tired and I didn't eat yet, so I'll take a break and probably continue off stream. So for whoever's watching, thank you for watching this stream. Thank you for stopping by, and I'll see you probably tomorrow. Bye.